Can you all see my screen, guys?
Yes.
Okay. So now, so what we are going to see in this course is that, as I said, I've broken this course in such a way that everybody should understand straight away, because we are going to go slow on certain topics before we jump into the C. Okay, the very first thing, Terraform introduction. So today, what we are going to do is today we are going to see Terraform introduction. I think majority of you might already know what is Terraform and why Terraform. So this is going to take only 5-10 minutes, but then this is something that I wanted to cover for today. That is how Terraform actually works. What are the different components that are involved? So, like majority of Terraform init, Terraform plan, and Terraform apply. Right? These are the three commands that majority of you might already know. But what happens when you do Terraform init? What happens when you do Terraform plan and apply? So those high level stuff is what we're going to see today, just to get some understanding straight for all of us. Okay, so today we're going to see the Terraform introduction part, and then we will jump into provider basics. Okay, what is the purpose of a provider? Like, because as I said, Terraform has a lot of, Terraform supports a lot of providers. And then how do you specify Terraform that it should go ahead and create an EC2 instance in AWS? Like, you need to specify out actually Terraform, like for example, you might have 100 friends, like for example, but you wanted to call a specific friend to tell something, right? So in that case, you will just call him, not all the 100 people. So similarly, there are a lot of providers that Terraform support. If you wanted to create something in AWS, you need to make sure that you're writing an AWS provider block, not the Azure provider block. So that is what we are going to see. Why provide? What is the purpose of having a provider is what we are going to see in the provider topic. Okay, and then we will jump into, in the next class, what we are going to see is we are going to jump into variables. Like, how do you write a variable, how do you declare a variable, and then what are the different ways in which you can actually pass values to a variable. Okay, so variable, in short, it's just a placeholder. It holds a value for it. That's all. Variables work is to hold a value for you, and wherever you need the value, if you reference the variable, it is going to copy the value and paste it there. Okay, that's the whole purpose of a variable. But here, there are different ways in which you can specify a value to a variable. We will be looking into all of this, and then I would be telling you which is the recommended one. But because these are all different use case that you still need, but I would teach you everything and say, hey, if you're put in a certain situation, you need to use this. In other situations, you need to use this, because I would give you a clear definition of where to use something and when to use something, right? And there are different types of variables, like string, map, list. There are a lot of types of variables. We will be seeing all the types of variables and what is the difference between one another. And then we will be jumping into outputs. So here we are going to see basic outputs. Okay, sorry about that. Okay. So in the outputs, what we're going to see is, here we are going to see a basic output, which is, if you want to display something on your terminal, how do you get that done? So that's the thing that we're going to see at outputs, because there is another output section coming up, which will detailedly explain like how you can fetch a, output from one resource and pass it to another, is something that we will be seeing, in the upcoming classes. So there is a deep dive class here. So there we will be seeing majority of the outputs. But here, just to set the ball rolling, what we will do is we will teach you outputs, like if you want to display something on your terminal, how you should do that. So that's a topic here. And then providers in detail. So I've told you that, Terraform can work with AWS, it can work with Azure, GCP, whatever it is. But when it connects to Azure, how can it connect? Like, because there should be like when you, if you want to, if I say, hey, uh, Richard, can you go and create an EC2 instance for me? So Richard knows that EC2 belongs to AWS. So what he would do is he would log into his AWS first, because without logging into AWS, he cannot create anything, right? So same way Terraform works as well. So you have to specify a provider block like this. And when you write this provider block, you are clearly specifying that you want Terraform to talk to AWS. Okay. But when Terraform wants to talk to AWS, you have to provide an authentication mechanism, right? Can you create an EC2 instance without logging into your AWS console?
Yes,
No,
with
no, I think you
with
didn't
the
get the
use
question.
of the
Yeah.
oh yeah,
Can
yeah,
you
Terraform
log?
has to authenticate.
Yeah, just think about a personal thing. I'm asking Butane to go and create an EC2 instance. Can you create an EC2 instance for me without logging into your AWS console?
No,
No, that's not
no.
possible.
That's not possible. So what you would do, you would go to your aws.amazon.com, you will give your username password, or your IAM username password, or you root email password. So only after authentication it is going to allow you to log into your account, and then from there on you can create your EC2 instance, right? A similar way Terraform works as well, but since you are doing it programmatically, you have to provide an authentication mechanism. Okay, there are different authentication mechanism. We will be seeing everything. By specifying the authentication mechanism, what Terraform would do is Terraform would use that authentication to communicate with AWS, and then it would create required resources for you as you've written. So we will be seeing everything in detail, like all the authentication mechanism that is available for AWS, and then what is the difference, and again which one to use at a corporate level, and which one to use if you're using Terraform Enterprise and stuff. We will all there are 4 to 5 authentication methods. We will be seeing all of it, and then then I would make recommendations when to use IAM rule, when to use environment variables, and things like that. Okay, and finally we will be on resources. I think majority of you, I think whoever is doing Terraform or planning to learn Terraform so far, what they would have done is, if at all they wanted to create an EC2 instance, or they wanted to create S3 bucket, the general tendency is that when you don't know the skill, you would just Google it up, and whatever you see there, you just copy it and paste it, and you might do a lot of trial and errors, and then eventually you will make it work. Okay, this is the normal process that everyone goes through when you are not fundamentally good about a skill. So here what we are going to do is I'm going to teach you how you should write your own resources, right? Where you should look at and how you should start, because there is something called as Terraform documentation where everything is available there. So what we are going to do is we are going to show you how to understand the documentation. Like tomorrow, if your boss comes up to you and say, hey, can you go ahead and create a Lambda? You should be able to do that without looking at Google or anything. Just go to straight away, go to Terraform documentation, and from there on, you can start writing your own code. We are going to teach you here how to do that. Okay, because majority of the people don't know how to go through the documentation. Even they go to the documentation, they just copy the example at the top, they copy paste it. That will give you only minimal stuff. But yeah, here we are going to teach you in detail about how to go about creating something, and how you should start writing your own code is something that we're going to see in the resource. And then again, as I said, outputs deep dive. So here, what we are going to do is here we are going to concentrate on arguments and attributes. That clearly we are going to explain you what is arguments and what is attributes, and how can you fetch an output from one resource and pass it on to the next resource or the other resources that is available. Is something, because this concept is going to be very key when it comes to Terraform modules. Okay, so I want all of us to understand this. So that's the reason this deep dive session is coming up. And we are going to jump here in the next thing. We are going to see a lot of commands. So by now, we are in slide 7. By now we would have used few of these commands. So in this slide we are just going to spend some 5 minutes just to explain what is init, what is plan, validate, apply, and format. That's all. It's just like a refreshing session. That's all. and then destroy infrastructure. We are going to see few commands of how you can destroy something, because when you can create something through Terraform, you should be able to destroy something to Terraform as well. Like, what are the different options available and how to use Terraform destroy? Because when you destroy something accidentally and everything is gone for, once gone is always gone. You need to go ahead and recreate. So how you should safely destroy something which is not required is something that we are going to see in this section. And then state files. I think I'm not sure how many of you know about state files. In Terraform, state file is one of the key topics. So it is important for everyone to understand how to read state file, like what data it contains and how state file is managed. So in the state file section, we will be deep diving into state file, what is state file, how to read a state file directly from the files, and what are the different commands that you can use to read state files in a more human readable form, because all the state files will be in JSON format. Some people have difficulty reading JSON format. For them, we have few commands in which you can run, and it's going to give you more user readable kind of format. So we will be completely deep diving into state files, and we will see how that goes. Okay. And then backend. Uh, Backend is a place where you can actually store your state files securely. Okay. Securely. Because if you keep your state file in your computer or someplace, chances of getting the state file deleted is more, because you can accidentally delete it and then accidentally change it. And also, if it is available in your computer, only you have access to it. None of the others will have access, because in a corporate in a corporate world, we have to we'll have to be working together as a team. So it has to be kept in a central location where everybody do have access to. At the same time, you need to make sure that the state file is very secure. I mean, secure as in nobody can come and accidentally delete it. Nobody can come and actually change it or do something like that. So backend is a place where you actually store your state files in a central location. So here, what we will be doing is we will be teaching you how to use S3 as a backend in order to make sure that all the state files, like whatever you create, the state file should go to a specified S3 bucket, and it should be stored there, so that you can recover the data. Means we will be enabling versioning and a lot of things so that you know that your state file is secure. And then data sources. Data sources is something that I'm going to explain you when to use data sources, what is the purpose, and how to use data sources and when. That is what we are going to see here. And finally, we will come to the topic which is most important of all: modules. Terraform is all about modules. Terraform is all about reusable. Okay. You will have to write code once and you should be able to reuse, because an organization might be needing hundreds of S3 buckets and hundreds of EC2 instances. You go and write your code 100 times, then which means that you are not efficient and your company is not efficient, because you are spending, even if you're writing an S3 bucket and it takes you 1 hour for provision, for writing 100 S3 buckets, it is going to take you 100 hours. Okay. But when you write a module, you write the code for one time, and then you will be able to reuse the same module multiple times. So means you will write the code for 1 hour, but whenever you want to create another S3 bucket might should take you only 5 or 10 minutes. So you are taking 15 minutes for each iteration. So module is a thing that you write it once and you reuse it as many times as you want. So reusability is one of the key concept of Terraform. So module. So then you might ask me, hey, this seems like an important topic. Then why this is coming at the end of the course? The reason being, if you don't understand all the other stuff that I've already discussed here, if you don't know how an input variable work, if you don't know how an output variable work, and how to create a resource, and how to pass an output from one resource into another resource, modules will not make sense. So that's the reason we have broken down into stuff. So by now, when all of us come to module section, you would be strong in all of those things, and modules will be like a cake. Okay, so that is what we are going to see in modules. And then as soon as the modules is done, we will be teaching you functions, but we are going to do it a little bit differently. I'll tell you how. Terraform Enterprise. So here in the Terraform Enterprise, what we are going to do is we are just going to give you a high level of So Terraform is two. One is Terraform open source, another one is Terraform Enterprise. So Terraform Enterprise is a paid version. You have different versions of Terraform Enterprise, but in short, open source is free, and Terraform Enterprise you will have to pay something because it offers you certain other features. So that is the thing that we are going to see. Should you go to Terraform Enterprise or not? We will see there, because Terraform Enterprise, going to give you a high level, because some organizations have started using Terraform Enterprise. So you might be in a situation where you might need to use Terraform Enterprise. So here we are going to give you a high level understanding of what Terraform Enterprise is, or what additional thing that, because since it comes at a cost, everybody should know what other things that Terraform Enterprise provides for which they are charging you. So we will see that. So with that, the course will complete. The course should complete in about 3 weeks. Okay, the course should complete in 3 weeks. And then for the next 3 weeks, what we are going to do is we are going to work on this real life capstone project. Okay, so the project is create an EC2 instance in an custom VPC. I think all of you might have already, whoever has practiced AWS, all of you at some point in time, you might have created your own EC2 instance, right? And it would have been very easy for you to create an instance. All you do is go to EC2 console, launch instance, you will click your T2 micro, you will click your AMI and OK, and it creates an EC2 instance for you. Why that is easy is because Amazon has made it easy for you, because every account will come with an default VPC. It comes with a default security group and default subnets. So everything is already created for you. Okay. Since everything is already created for you, and then by default, if you don't specify anything, AWS assumes that you wanted to create an EC2 in the default VPC. That's the reason it is easy. But nobody uses default VPC at an organization level or a corporate level. Nobody uses default VPC. In our corporate level, we create our own VPC so that you can, you can make it secure with whatever standards that you want. Okay, so creating a EC2 instance in a custom VPC, in order to create an EC2 instance in a custom VPC as in your, apart from default VPC, any other VPC that you create is a custom VPC, because you are customizing that VPC to your needs. Okay, so when you want to create an EC2 instance in a custom VPC, first of all, you need to create your own VPC. Okay, when you create your own VPC, you need to create your subnets, internet gateway if you want, NAT gateway if you want, route tables, every other networking component that is required, you will have to create it first. Only then you can create an EC2 model. Okay, so in this project, what we are going to do is, first of all, we are going to build a VPC module. We are going to build a security group module, and we are going to build a EC2 module as in reusability. So we are going to create 3 modules which will be usable, which will be reusable. And then once the module is ready, we are going to deploy the VPC security group and EC2. So once we are able to successfully deploy all these 3 things, which means that our project is completed. Okay. While building this module, functions are the key elements, because function makes your life a lot easier. Okay, so while building the modules, what we are going to do is we are going to see all the common majority. So Terraform has around 80 to 90 odd built-in functions. Okay, but not all 90 functions are used. It is there for us. If you want, we can use it, but we are going to see commonly used function, about 10-15 commonly used functions. And then we are going to see 2 key concepts like Terraform for each and dynamic, because these 2 are also a kind of a function, but this will make your life a lot easier. So what we are going to do is, while we are building a module, we will be seeing functions. So, I'm going to write a module, I'm going to write a block and say, hey, this can do something. But if you add functions like for each or dynamic, it is going to dynamically create you a lot of stuff. So I will explain. While building a module, we will parallelly teach you functions so that it makes clear sense, because teaching functions separately and teaching modules separately, you might have to, rethink a lot and do it. So what we are doing is, we are, after modules, we will skip this and we will jump to enterprise. And when we are doing the project, In tandem, we will be teaching you functions so that it will make clear sense to all of us. Okay, so that is what we are going to, this is what we are going to do in this. So once this project is done, our course is done. Any questions, guys? This is what you're gonna learn with us for the next 6 weeks, 6 to 8 weeks, if at all we delay certain classes. But other than that, we should be on schedule if everything goes well. Any other questions for me here? No questions? Okay, cool. I think, okay, cool. I think most of you might already have this course content. I think I did send it to Primus and all the personal contacts, whoever are joined directly, with my customers also should have this. So what I'll do is, but for the benefit of everybody, what I'm going to do is I'm just going to send this I'm going to drop this in the drive and give access to all of you guys. So if at all you wanted to revisit this, you can do that. Okay, so now if you don't have any questions, I'm going to move forward, which is, and one more thing, don't think that I'm going to teach using this, using this PowerPoint. I am not a person to teach directly from, not going to read the PowerPoint. So this is just the course content PowerPoint. We are going to see this just to see if we have covered everything. That's it. Other than that, this is just for uh, giving a detailed view of a course content. That's all. So majority of the stuff we will be aware. No, we will do it on our Visual Studio Code. Okay. So today we will cover all this. So what is IAC? Why do we need Terraform? And little bit of Terraform introduction, and then finally how Terraform works behind the scenes. So this is what we are gonna see now. Okay. So now I'm just gonna open a whiteboard. Just let me know when you all can see my whiteboard. Can you all see my whiteboard, guys?
Yes.
Okay, thanks for confirming. Right. Okay. So yeah, somebody has something. Okay. Cool. So what is an IAC, guys? I wanted it to be more interactive, so feel free to unmute and speak. What is IAC?
Infrastructure as a code.
Infrastructure as a IAC is infra as code. Okay. What does it mean by infra as code?
That's being able to provision our resources in an automated manner where it helps us avoid errors and is consistent and
Yeah, thanks for that,
it has so many advantages.
Yeah, exactly. There are a lot of advantages. Let's not dig deep. So infrastructure as code is infrastructure is nothing but any resources that you wanted to provision, be it S3 bucket, be it virtual machines in Azure, or whatever it is. Anything that you wanted, any infrastructure that you wanted to create, what we are doing is we are achieving that through code. Okay, so you write the code, you execute it, and the code goes ahead and creates an infrastructure for you. Okay. So when you do that, what happens is, what are the benefits of that is, you can use that, you can reuse that code. If you are writing that as a model, you can reuse it. Okay. So now let's take a scenario. Gokul is creating an S3 bucket. Okay. And Laura is creating an S3 bucket. And Burton is creating an S3 bucket. So 3 people have been tasked to create buckets. Okay. So do we think it is possible for us all 3 to create the bucket consistently with the same settings and same configurations?
If we're doing it through the console, it wouldn't be possible.
If it is in console, yes, it is never possible because we are prone to make errors. Okay, so and also it is possible, but what you need to do is you need to allow someone to complete the S3 bucket first, and then you need to copy all the settings in your S3 bucket. So that's the way. But when you have a code and that code can be reused, then you can consistently, though tomorrow Gokul might not be working for this organization, but I might, all three of us can leave and new people can come and take over the project. For even for them, they can be able to consistently go ahead and create something because it is code and the code is reusable. So the same, the code has the same configuration unless until somebody goes and change it. So, you can consistently create. So that's the reason what we do is majority of the organization wants to go and do it in a coded way because the code is available, then you're not dependent on anyone. And there are very less errors because the code is well documented and well written so that it can consistently go ahead and create resources without any problem. Okay. And also, second thing is that it is going to save a lot of time. As I said in the earlier example, if in order to create 100 S3 buckets, you might need 100 hours. But if you have a code and if you have the option to reuse it, it is not going to take 100 hours. No, it is going to be much quicker. So, it saves a lot of time when you go to infrastructure. So when you go talk about infrastructure code, there are a few other infrastructure code as well. Okay, there are a few other infrastructure code as well. So you have CloudFormation. Okay, you have CloudFormation. I think everybody who have learned AWS will know what a CloudFormation is. CloudFormation is also an IAC. Okay, and Terraform is also an IAC. Terraform is also an IAC. Then when AWS or CloudFormation is something that is related to AWS itself, then why do you think people need Terraform? Okay, why do you need people need Terraform is?
I mean,
Yeah.
I've CloudFormation is more, it's like hard coded. It's work only on AWS, while Terraform is an open source. It can work on any provider.
Yes. So there is a term called as Terraform is cloud agnostics. Okay? Terraform is cloud agnostic. What do you mean by cloud agnostic is that, which means that Terraform is not tied to any project, any provider like CloudFormation. So CloudFormation will work only on AWS. Okay. And similarly, there is something called as ARM templates. Okay. This ARM template is Azure Resource Manager templates. So this will work only on Azure. Okay. This will work only on Azure. Okay. So means CloudFormation is tied to AWS and ARM templates is tied to your Azure. But Terraform, because it is cloud agnostics means it is going to work with multiple providers because it's not something linked to a particular project. It's an open project which will be which will be able to support you a lot of things. So that's the reason people wanted to use Terraform because it is cloud agnostic. It is not tied to any project or any provider or any cloud. Using Terraform, I can go ahead and create stuff in AWS. I can create stuff in Azure, GCP, and there are Terraform closely support, Terraform right now it supports around 2,700 providers. Okay. So using Terraform, you can do a lot of things. Another benefit of Terraform is that if you know how to write Terraform is going to be the same, like the way you write variables, way you write outputs, the concepts, the syntax, everything is same. It's not like you want to do something else for AWS and something else for Azure. So today, if you're learning Terraform on AWS and you master Terraform, tomorrow, if your organization wants to use GCP, using the same knowledge, you will be able to write code for GCP also, provided you have GCP skills. Because as I said, Terraform is not standalone. You need to know the skill before you do Terraform, right? So today, if you learn Terraform in AWS, and tomorrow, if you want to know, with the same knowledge, you can easily start working on GCP because, as I said, everything, the concepts and the way you write and how Terraform works, everything is just the same. Just that instead of creating an S3 bucket here, you might be creating something else there. Just like you are creating an EC2 here, you might be creating something else because the concept is same, just that how GCP creates and how AWS creates and how Azure creates and the names of it are different. Okay. Does it make sense, all of you?
Yes.
Yeah.
Yes.
And you don't have to feel shy. Uh, Sometimes I have the tendency to speak a little too fast. So if you don't understand something, or if you're not following me, or if you have a doubt, please stop me and ask your questions, because this course is for you to learn something. So whenever you're not following up, hey, can you just stop me and say, hey, can you repeat that? I'm very happy to do it. Don't just sit idle, thinking. Don't feel shy. Feel free to open up, and feel free to stop me and ask me questions, or if you don't understand anything. Okay. Right. So since Terraform is cloud agnostic, majority of the organization wants to use Terraform, because what happens is now majority of the organizations are going through a multi-cloud strategy. Okay. So what is multi-cloud? As in, they might use certain services from AWS, they might use certain services from Azure, and certain services from GCP. Okay. In this case, without Terraform, think without Terraform. Let's assume that there is no more Terraform. So what ideally people will do is they will use CloudFormation for AWS, and they will use ARM templates for Azure. So now, whenever you want to hire a new engineer, the engineer should know CloudFormation as well. He needs to know ARM templates as well. Okay? This what happens is this will create an operational overhead over time, because you might need to have engineers with multi skills, and then you need to manage all these codes differently, and there are a lot of problems here. So but by knowing Terraform, and you start using Terraform, it's easy, because Terraform works on AWS, it works on Azure, it works on GCP, it works on a lot of other things. So, and also an engineer who is good with Terraform, and in at least in one provider, he should be able to easily learn other stuff quickly. So that's the reason, majority of the organizations are currently using Terraform. And, Terraform has grown a lot. I started in 2006, I started in 2017, 17, 18, and Terraform has significantly improved, and there are a lot of capabilities added. So that makes a good fit for majority of the organization to start using Terraform. Okay, so this is all about IAC. Why you need Terraform? Simple. Why you need Terraform is something that I've given here, and then from an Terraform perspective, I'm going to show you the documentation. So this is the official official page of Terraform. Terraform.io is the official page. If you wanted to look into any sort of documentation, or hey, I wanted to know all the provider list and stuff, there is something called as registry here. Okay, there is something called as registry here. So just go to the terraform.io, and then just go to registry, click on registry, and this is the landing page of all the providers that Terraform. Okay, so you can see browse providers. So there are totally 2767 providers, 2767 providers so far. So it means each provider is each product. Like AWS is one provider for Terraform. So similarly, Terraform supports close to 2800 providers, and there are a lot of modules already written for you. If at all you wanted to reuse these modules, you can feel free to use it. But for now, if you're a beginner, I would say don't use these modules, because these modules are complex. Complex as in they might have considered all different scenarios, and they would have used a lot of functions to do this. So if you don't know Terraform, going through this module, it'll give you a panic attack, because there are a lot of complex functions used. So for at this moment, you can ignore these modules for now. Maybe after this course, you would be familiar with a lot of functions. So that time going and referring these modules is going to make a lot of sense. But from for now, just stay away from here. Okay. So now if you click on this browse providers, it is going to give you, it is going to list down all the providers that Terraform support. Okay. How Terraform is segregated it is, they have segregated into three tiers. One is official, another one is partner, and the community one. Okay. So what's the difference? So official one is owned and maintained by HashiCorp. Okay. Whenever you see an official tag, these are owned and maintained by HashiCorp. Okay. And whenever it is partner is something where it's a partnership between the actual partner and HashiCorp. They work they work in tandem, and then they go ahead and publish. Okay, and the third one is community. Community is that anybody can write and anybody can use. Okay, now why I'm explaining this and what is the importance here is that for official and partner provider. Okay, so now Kappa is using something. Kappa is using Google Cloud Platform, and he's writing a code and he's executing it, but he's facing an error. Okay, and he thinks that is a bug. Okay, he thinks that is a bug, or he don't know how to do a particular thing. So what he can do is he can raise a ticket with HashiCorp, and somebody will be able to assist him if somebody thinks that is a valid bug, or if Kappa is asking, hey, can you enable this feature, I think that is going to be useful for me. Whatever concerns he has, he can raise an HashiCorp ticket, and they will be they will validate it and they will help you how to do it. Or if they think that this feature is going to benefit a lot of people, they will add that feature for all of us. Okay, means you get the support. But whenever you're using a community, you are not going to get the support, because these are like a free, like I think today, let's think of a let's think of a scenario here. I wanted to manage all my password. So then I thought, hey, why can't I write my own plugin? So these all providers are written in Go language, so anybody who knows Go can write providers, Terraform provider. So I'm thinking, okay, I wanted a password solution, so I wanted to develop my own password solution, and let's assume that I have done that successfully. Now I'm thinking, okay, this password solution can be useful for people out there in the world, right? So what I can do is I can come and publish that in Terraform here. Okay, and let's assume that Samuel here wants a similar password solution. He wants to manage all his password, and he's googling around, and then finally he found what Terraform already has. So what Samuel can do is he can start using this provider, because we go to this provider, it has a lot of resources and stuff, and Samuel can start using this provider. Okay, this is a community provider. But what is a problem that Samuel is going to face is, let's assume that Samuel is using this and he is stuck somewhere, or he thinks that he needs couple more feature here to to save different things. So here Samuel is completely dependent on me, because I am the owner of this provider. Okay, so Samuel should request me only if I have the time, and if I wanted to help Samuel, I'm going to help him, or else I'm going to say, hey, currently I'm too busy. Let's look after 6 months. So when I say that, Samuel is stuck with me for 6 months here, because if he wants a feature, he has to wait, because this provider is not official or partner provider. This is a community provider, because as I said, anybody can go ahead and publish a community provider and anybody can use it. But you are stuck with me. You are stuck with the owner. If he is generous enough to help you, he can help you. Only if he's free, he can help you, right? Or else there is no point for him. So for that purpose, I would always recommend to use official and partner providers, because even if you're stuck, or if you if you're seeing a bug, or if you want a new feature to be added, you can always raise tickets with that. That's the only difference between official partner and community. From a community provider, nobody can guarantee you what kind of support you might get. But official and partner is something that you will definitely get support from provider. That's the different tiers. So, and also, in order to make it easy, Terraform has, with all the providers, so there are totally 2,800 providers. They have categorized it to different category, like database. So if you go to, if you go to container orchestration, so up in totally you have 91 providers that is related only to orchestration of containers. And similarly, if you are looking for anything with networking, if you click here, it is going to list down, see there are 180 providers related to networking alone. So these are like subcategories. Depending on the categories, you can choose and use whatever you want. Okay, is it clear, guys? Any questions here? Any questions?
I just wanted to ask, like, what if you used a partner provider and you wanted to raise a ticket?
Yeah,
Is
that is
it?
what I said. Official and partner are pretty much the same. You get the support. Okay, so what happens is
Are you
this.
getting the support? Are you getting the support directly from?
Yeah.
Let me say. Let me say. Let me just say Boundary is a third-party partner for Azure. I'm giving an example. So if you were to raise a ticket with the Boundary, how would it work? Would it go straight to Azure, or is it it
No.
would
Okay.
handle?
Okay. Right. Good question. So what happens is, so now if you're facing a problem with Azure, like you are doing something on Azure with the connectivity to Boundary, right? So you need to create a ticket under Azure's. So for every provider, there is a separate channel in GitHub. Okay. So if you're facing, so I think, like Terraform. So see, I'm going to show you. So if you see the Terraform issues here, now this is the official one. Okay. So for HashiCorp, they have different repositories. Okay. So for AWS, they have a Terraform provider for AWS repository. And similarly, you have Terraform provider for Azure. Okay. GitHub. Okay. So what HashiCorp has done is, so under the hood HashiCorp, okay, HashiCorp is the parent here. So under this, they have lot of repositories. Okay, see, this is for Azure, this is for Autoscaler, and this is for Boundary, this is for Dev Portal. So this is for Vault, Google Beta, Google. So for every provider out there, what Terraform, HashiCorp has done is it has created a repository. So now if you're working with Azure and you have some problem, what you need to do is you need to go to this Azure repository, and here you can raise a new issue. So if I'm facing an issue now, I will go and click on the new issue. I'll sign up. So now if you see the open issues, see there are 22 2,235 issues open. So now everybody have created for different needs. See, there are a lot of things. So these will be worked upon. So if you're facing an issue with Azure, you will go here and you can raise a new issue. They will look into it and they will give you suggestion. This happens for both official and partner. What is the difference is, the key difference is that you will get the support from HashiCorp for both of it. Only the key difference is that official, these are owned and maintained by HashiCorp themselves. Okay. These are owned and maintained by HashiCorp themselves. In case of partner, the partner will own it. Partner, it's like a co-own. What happens is the partner will do the majority of the development, and HashiCorp will help them test it. And only after everything is successful, Terraform is gonna. I think if you see here, partner provides are owned and maintained by the technology company. Okay, but it is maintained a direct partnership with HashiCorp, because before publishing it, Terraform will make sure, HashiCorp will make sure everything is tested and everything is working stable before they get released to you. So for both of it, you will definitely get the support. But for community, you never know, depending on the author.
Thank you.
Any other questions, guys? Okay, cool. Right. So this is about Terraform. So now what we are going to do is we are going to see a high level of how Terraform works behind the scene. Okay. So now I'm going to add some shapes. I'm going to add some shapes. I'm going to add one. I'm going to add. I'm going to add 3 shapes here. Okay. So and then I'm going to add text. So this is with dot here. I don't know why I'm not able. Okay, let me type it here. So, okay, so let's see how Terraform works behind the scene here. Okay, so I'm gonna right. So here, this is any files. Whenever how do you want to differentiate? Is that any if you are writing a Terraform configuration? Let's assume that you are writing a Terraform configuration. The file should always end with an extension .tf. Okay, the file name can be anything. The file name can be anything. I can write even gokul.tf, but the extension, the extension should always be dot .tf. .tf is the extension. Any code that you write for Terraform, if you want to save that file, the file should be saved in the extension .tf. Okay, here we are going to write the code, and let's assume, for now, let's assume this is our AWS account. This is our AWS account, and this is our state file. This is our happens. Like now, let's say I wanted to create an EC2 instance, and let's use this example to explain how Terraform works behind the scene. So now, as I said, I wanted to create an EC2 instance. Okay. So EC2 is related to AWS. So first of all, I will go ahead and write an AWS provider block. Okay. I will write an AWS provider block. In this AWS provider block, I said I have to specify the authentication inside the block, because without the authentication, Terraform will not be able to communicate with AWS. Okay. So the very first thing is that I will write my provider block, and I will say, hey, Terraform, I want you to connect with AWS using whatever authentication that I have specified. Okay. The next thing what you will do, you will start writing. So you will write a resource block for instance. Okay. You will write the resource block for instance. Okay. Let's assume that I wanted to create a T2.micro instance. Okay. We will write a resource block. This is not the correct resource block. I have written it just for explaining. So I wanted to create a T2 micro instance. Okay. So what you have done is you have written the code, you have saved it in .tf. So you have saved this as main.tf or ec2.tf, any file name .tf, and the end should be .tf. The extension should be .end.tf. So now you are good to create this EC2 instance. So what you will ideally do is you will come here and you will run Terraform commands. What is the Terraform command? First of all, you will run Terraform. Why this? So you will first of all write Terraform init, and then you will run Terraform Plan, and then finally you will run Terraform apply. These are the 3 commands you will do. So while initializing, Terraform will initialize your stuff. And when you run a Terraform Plan or a Terraform apply, what actually happens is Terraform. So now Terraform knows that it has to communicate with AWS. So it will use this authentication, and using this authentication, Terraform is going to make a communication to AWS. Using this authentication, Terraform is going to try and log in into the AWS programmatically. Okay. Because using the authentication, okay, if the authentication is valid, AWS will allow Terraform to create the EC2 instance. This is our EC2 instance. Okay, if the authentication is valid. Let's assume that the authentication is not valid, you will get an error saying that you are not authorized or you don't have enough privilege to create this EC2 instance. Okay, so key here is that in order to Terraform should know who Terraform is talking to and using what authentication. So if Terraform is talking to AWS, you need to write a AWS provider block with the required authentication, and the authentication should have proper permissions. If the authentication do not have permission to create an EC2 instance, you will get an error. That is what. So it uses this authentication to make a communication to AWS. AWS will validate whether this authentication is correct or not. If the authentication is correct and successful and it has enough permissions, AWS will allow to create EC2 instance, or this Terraform plan will fail, saying that Terraform plan or Terraform apply will fail, saying that hey, whatever authentication that your provider is not valid, or you don't have enough privilege to create this. Okay, these are the 2 possible scenarios that can happen. Okay, if the authentication is successful, the resources gets created. If it is not, you will get an error. Okay, is that clear, guys?
Yes.
Oh, so Terraform, as part of this process, it will not only create this EC2 instance. As soon as the EC2 instance is created, Terraform will do one other stuff. Okay, that is making sure all the metadata of this EC2 instance are stored in a file called a state file. Okay. As soon as the EC2 instance is created, any details related to EC2 instance, like what is the public IP or what is the private IP, and here we are getting T2 micro. So the type is T2 micro here, and instance ID, instance ID is there, and whatever security group that you have attached to this EC2 instance, everything will be stored in a file called a state. Okay, the state file is auto-generated by Terraform. You don't have to create it. Whenever you run a Terraform apply, Terraform will automatically create the state. Okay, and what is the purpose of state file? Whenever you create something, Terraform is going to make sure every data of this EC2 instance is saved here. Like, I say, like the metadata, the parameters of EC2 instance, like instance ID, public IP, private IP, and DNS name, and whatever it is going to store in this file called a state file. Okay. Why Terraform needs is that, so tomorrow, so you are creating this through Terraform. Tomorrow, anybody can go on the console and can change the properties, right? Terraform state file will make sure, no, by having a state file, Terraform, tomorrow when you run Terraform plan, it will clearly point out that somebody has done a manual change. So for that purpose, state file is key. And the next thing is that tomorrow, if you're writing another resource, instead of, now you are writing resource, tomorrow you are writing, you are creating an S3 bucket here. Okay. So you are creating an S3 bucket here. So Terraform will not recreate this, because looking at the state file, Terraform knows that this resource has already been created. So this is the newly added code. So Terraform will go ahead and try to create only S3 bucket. It will not recreate your EC2. This is already created. The references for the creation of this is available in your state file, because for every plan and apply, Terraform will refer the state file before it actually does something. Okay, does it make sense, guys? Any questions here? Any questions here?
So I have a question.
Go ahead.
So before you deploy a Terraform file, you save it. And then when you save it, if it's deployed in AWS, it gets saved in the state file. Is that how
only
it
when you're
works?
creating. Only when you're creating. So you can write the code, you can save it. Nothing will happen. When this infrastructure will actually be created is when you run Terraform apply command. Terraform apply command is the one. So it's like simple, right? You wanted to shop something online, right? You can add it to cart. You can add as many to your cart, right? Unless until you go and check out and pay for it, you're not going to get that product delivered, correct? Similarly, unless until you do a Terraform apply, your resources will never be created. So init is just an initialization. Plan will show you, just like your cart, your plan, the cart will show you the final amount. Let's say you have put 5 items in your cart. It is going to say, hey, this 5 item will cost you $1,000, for example, right? It is just giving you an estimate, right? Similarly, plan is going to just give you an execution plan, like what will happen when you do something. And finally, only when you do Terraform apply, the infrastructure will be created. Only when the infrastructure is created, the state file will be updated. Okay. So tomorrow, if you change the properties in the EC2 instance and apply, that time the properties in your this EC2 instance will be modified, and that time the state file also will be modified, because the parameters are changing. The parameters will be stored properly.
So each resource has a state file. Each resource that's deployed.
No, not each resource. So now let's say, now if you're writing all of this code in the same folder, let's say you have one file which is creating EC2 instance, you have another file called s3.tf which is creating S3 bucket. So it's on a folder level. Terraform works on a folder level. So every resource, whatever resource that you're trying to create in the same folder will be saved in the same state file.
Perfect.
Just like every house has its own address. No, you will not have an address for each of your rooms inside your house, correct? So you have a house. So, inside it can be, 5 rooms, 10 rooms, whatever it is, but you have a single address for your house. Similarly, if whatever resource, you can create hundreds of resource, and if the hundreds of resource in the same folder, it will just create only one state file.
Thank you.
I think Kappa was about to ask something.
Yeah, so I'm writing all what you're saying down. So we can say a state file contains more information about the resource.
Yes.
Okay.
I'll tell you what. Okay. I'm not done. I'll tell you what. Okay. So here, right, this state file and your code. So this is your code configuration. and this is your state file. So your state file and code together is called as a desired state. Okay, this is your desired state. Okay, your configuration and configuration with your state file is called as your desired state, and AWS is your current state. Means whatever resources that you see on your AWS is your current state. Okay, so whenever you run a Terraform plan, okay, when you run a Terraform plan, it does something called as Terraform Refresh also. Refresh is part of your Terraform plan. Okay, refresh is part of your Terraform plan. So whenever you run a Terraform plan, Terraform will ensure whether your Terraform current state and desired state are equal or not. Okay, how Terraform knows whether the desired state and current state is equal is looking at the properties here. So what refresh will do is refresh will send an API call to the actual resource. Okay, it's going to send an API call to your EC2 resource, and it will fetch all the parameters. Okay, and then state file has all the parameters, so it is going to compare both of it and see whether it is same or not. Okay, so Terraform plan will always ensure whether what is your state, what is your current state, whether the both the states are in sync or not. Okay, if it is in sync, it is going to say, hey, everything is up to date, you don't need to worry. And whenever it is not in sync, it is going to show you, hey, the configuration has drifted, please have a look, something like that. Okay, now let's, again, for here, let's look into an actual example. So what is this EC2 instance? This EC2 instance is T2 micro. Okay, we know because in the code, we have clearly mentioned to create a T2 micro, right? We have created T2 micro. So now, for some reason, okay, so now let's say there is an audit coming up tomorrow. There is a compliance audit coming up tomorrow. Okay, let's leave over the compliance stuff. So this T2 micro, Samuel is working on this today, and he found out that when using this instance, the performance was not great. Okay, Samuel is using this EC2 instance today to do some activity, and the EC2 instance is very slow. It is hanging up. So, Samuel, the performance was not great. So Samuel was looking at it, and then he figured out the T2 micro, the CPU is around 90%. So which means that the load, the EC2 is not able to, it is overloaded. There are too many tasks running. So EC2 was not working well. So what he wants, then he thought, since there is less CPU, he thought for this, whatever load he is doing, T2 will not be useful. So he has upgraded it to M4X large. So, but on the console. Okay, he wanted to do it quickly because it is already 90%. Anytime the EC2 instance can, get terminated, because if the utilization goes 100%, the EC2 instance will be automatically terminated because it will not be able to handle more load. So it is going to get crashed and it's going to terminate. So he don't want that to happen. So he immediately stops the EC2 instance and makes this changes. Means from T2, he has upgraded it to M4 manually on the console. Okay, on the console. And then he forgot about it. Okay, let's assume he forgot about it, that he made a manual change. So what happens is tomorrow, when Kappa goes and runs this code, he's going to run a Terraform plan. So now, do you think the current state and desired state is equal?
No.
So how Terraform will identify is that, okay, when you run a Terraform plan, as I said, as part of the Terraform plan, Terraform will internally run a command called as Terraform Refresh. The refresh will go and, it will trigger an API to EC2 instance. It will fetch all the parameters. So when it fetches all the parameters, the EC2 instance type will be M4. Okay, but the actual in EC2 instance type that is stored in your state file is T2, because the code says it is T2, because state file is a byproduct. Okay, you can't create it. Terraform creates it depending on the code and the execution, right? So whatever you have here, you will have here. So now the current state is in M4, but the desired state is in T2, which is not equal. So in this case, the Terraform plan is going to say, hey boss, there is a Terraform drift and I wanted you to change one. There is one item to change. That item is that I am going to revert back M4 to T2 because the code says T2, the state file says T2, but the current state is M4. The one change that Terraform is going to suggest is that I'm going to change the code, I'm going to change the EC2 instance from M4 back to T2. This is the suggestion it is going to make. Okay, because there is a drift, because somebody has done a manual change. Okay, somebody has done a manual change which is conflicting with your code and your state file. So whatever is conflicting, that is called as a Terraform drift. Okay, drift, because it has drifted from the desired state, because the desired state should be T2, but it has drifted from T2 to something else. So whenever you run a plan, Terraform is gonna show you. I know Kappa wants to ask something, but I'll put him on hold for a second. So what happens is Terraform drift will show you this. Okay, so now people can ask me, you might think, can Terraform automatically notify me, hey, somebody has done manual change? Okay, if you have this question, somebody is doing a manual change, can Terraform notify me that somebody is doing a manual change? The answer is no. Terraform is not a notification service. Okay, Terraform is not a notification service, so it will not intimate you whether somebody is doing a manual change or not. That is point number one. And the second thing is, hey, somebody has a manual. I told you clearly that whenever EC2 instance is created, the parameters of it will be stored in the state file. So somebody can think that, okay, when somebody does a manual change, will the state file will be automatically updated to match the parameters to M4? If you have this question, the answer is no again, because as I clearly said, Terraform is a byproduct of Terraform commands only. Okay, whenever you run a Terraform command, that is the only time the state file can be created, can be modified. Okay, modification includes addition and deletion. So the state file is a byproduct of Terraform. So only when you run commands, these commands, Terraform init, plan, and apply, the state file will be created and modified. Okay, modification includes deletion as well. That is removing something of the state file. So this will happen only when you run commands. So just because this state file is related to EC2, any changes manually made on EC2 instance will not be automatically updated in your state file. Okay. So since this is a byproduct, for the same reason, you should at no circumstances go and make manual changes in the state file. You should just let Terraform to do its work. You don't want to, hey, I've changed something, I'm going to update the state file. Never, ever, ever update state file manually, because when you change something, the chances of Terraform state file being corrupted is high. So which means that you need to do a lot of state imports. That is hectic, right? So Terraform is not a notification service. So any resource that is created by Terraform, somebody is making change, Terraform will never notify you. Point number one, because it's not a notification service. And second thing, when an infrastructure configuration is changed, the state file will never be updated automatically, because Terraform state file will be updated only when you run explicit commands like init, plan, and apply. Okay, so these are the two things that you need to keep in mind. Yeah, I think let Kappa go first, then I'll respond to Burton. Yeah.
Okay, so it means the Terraform state file is just like a control. It's a binary file. It is a binary file that can not be changed manually, and also
you can change
for
it
my
manually. It'll allow you to change. It is not a complete binary. It's just a JSON format file. Okay. I think I will. Yeah, I can show you shortly. It's a JSON file. Anybody can go and update it. It's not a binary. Okay, it's a JSON file. But if you change it, chances of it getting corrupted is high. So I would recommend you not to do any changes on your state file directly.
Okay. Oh, okay. And another thing. So I'm trying to like apply the knowledge. So the Terraform refresh and the Terraform plan is just like a git diff. It's just like running the git diff command to.
No, not a git diff. It's like an actual execution plan. Okay. So it's like you want to construct a house. So you have the design in place, right? You have a design. You go to an architect and he's going to design an house for you. And if you're happy with the design, then you will allow him to start constructing the property, right? So it is a design. Like when you run a plan, it is going to clearly say you, hey boss, I'm going to create 2 resources. I'm going to change 1 resource. I'm going to delete 1 resource, depending on the code. It's just an execution plan, because when you apply it, it is going to create 2 resources, it is going to delete something, and it is going to change something. So that is, it is going to clearly show you what it is going to do. It's just a plan.
Okay. I was
Yes.
talking about like refresh.
Yeah, refresh is exactly. So refresh, what happens is, you can't compare it with the git diff. Git diff is a little bit different. So what happens is, it's comparing. Yeah, it is a comparison between your current state and desired state, and it shows you the result. Yeah.
Okay.
But in
Prof, so the question I was going to ask was so the state file it contains like your desired state. So now when you make manual changes and that state file has your desired state, which is t2.micro, why does AWS let you actually execute that change if you have a desired state as t2.micro? Why does it not automatically revert back to the desired state?
Okay, see, right. So see, that's fine. Okay, that's a valid question. But why do you think that AWS wanted to do it? Let's say, see, you created the code to create EC2 instance. Okay, one from your team has done manual changes. So how do you think that AWS cannot decide whether you are doing it purposefully or by mistake, right? The AWS cannot police you all the time. Does it make sense? It's
Yes,
you, yeah,
it does
because
make.
AWS has given you, it's your account, so you are going to use it. So AWS will not come and say, hey, whatever you're doing is wrong as per Terraform, I'm going to revert it, because there is no that friendship between AWS and Terraform, right? Because you wanted EC2 instance, you can create that through console, you can create that through Terraform, and you can create it through any other ways. Okay, AWS is going to allow you to do that. So in that case, whatever questions that you ask, maybe from your case, it has to stick to the configuration, but currently there is no that that policing around, to make you revert it back.
Okay, it was just I just asked it out of curiosity because I was
No,
trying
that's
to
fine.
apply the
I'm not
concept.
saying that your question is wrong, or I'm not saying your question is stupid. What I'm trying to say is, you have the control to do anything with your account. So AWS cannot, put a restriction on you saying, hey, you can't do this because your Terraform code is something else. Because for AWS, Terraform is something else. Terraform is a third party for AWS.
Okay.
Right. So in that case, AWS cannot revert back according to, there is no, you think of AWS and Terraform is not friends, right? So, if your
Yes.
if a teammate wants to do some manual change, AWS will allow him to do it. Okay. So what you need to do is you need to make sure that your team is well informed that any changes that you will do, it has to be Terraform. Okay. Don't do manual changes. If you do manual changes for whatever reason, make sure that you revert it. It is something that you need to create that culture within your team.
Okay.
Yeah.
Thank you.
Yeah. I think somebody has dropped a message saying, what is a binary file? So binary file is an executable file. Okay. Which you can't read. Okay. Binary file is like an exe file. For Windows user, it's an exe file. Because if you try to open an exe file, it is going to give you all foreign words and foreign letters, like alien words. Okay, you'll not be able to read it. This plainly an executable binary. That is what they call it, binary. It's compiled and it is put in a different format that even if you open it, you will not be able to read what is written. Okay. Any other questions here, guys? Any other questions? Okay. If nobody questions, if there is no question, I will continue from here on. So now, as I said, so now there is a change. Let me reiterate, there is a change. So now when you run a Terraform plan, it is going to clearly say, hey boss, I have one to change. I am supposed to be T2, but somebody has changed it to, the current state is M4. So the plan which I want to change, which is I'm going to change this back from M4 to T2 because the code is T2 and the actual current is M4. So now here I have two options. One is that if you're happy with this, so now Samuel has done, though he has done it manually, he has done because of a reason, because the T2 was not able to hold the load. So which means that you need a higher CPU and a GPU. So he has changed it to M4. So now tomorrow, even if you go and change it back to T2 micro, tomorrow when he runs the same kind of testing or whatever it is, he is going to face a similar kind of performance issue. So which means that T2 is not fit for the purpose here. So we need to upgrade it. But so there are two chances. One is that reverting back. And second thing is that keeping M4 as it is. Okay, reverting back to T2 is one option and keeping M4 is another option. Okay, so now let's see what should I do if I want to keep T2 and what should I do when I want to keep M4. If you want to keep T2, the code is already T2. All you need to do is when a plan says want to change, just go and apply it. Okay, if you go and apply it, Terraform will automatically revert back to T2 from M4. You just Terraform apply it because the plan is clearly saying want to change, and the change is that I'm going to move from M4 to T2. Okay, if you wanted to revert back to T2, you will just go and do a Terraform apply. Apply will do. As per the code, it is going to change. So means the EC2 instance will be changed back to T2, and anyway state file is T2. It is going to stay the same. So now the second option, I wanted to keep M4 and I want to move away from T2 and I want to keep M4. In this case, all you need to do is the current state is already M4, but the code says T2 micro. So if you wanted to persist that manual change, if you want to persist the manual change, what you will do is you will go to the code. Instead of this T2 micro, you will make the code change to M4.xlarge or double xlarge. Okay, so now you are updating the code and your desired current state is already M4, so you are making the code change as per your current state. Now when you do apply, it will change the state file to M4. So now everything is synced. Okay, so now as soon as this is done, your current state is already M4. Now your code and desired state is changed to M4. So now these both are synced. Does it make sense? And another thing, so whatever I'm teaching here in theoretical terms, the same will be taught in your practical terms as well. So what I'm trying to do here in this overall picture is that I am teaching you different concepts, because see, in this concept, I have taught you provider, I have taught you resources, I have taught you desired state and current state, and I taught you state file. Okay, so these are all different topics. Okay, so I wanted to set the high level architecture in your mind, so that when we drill down into each topic, you will be able to easily correlate. So what I'm trying to say is don't dive too much into it. The same thing, the drift and other things, I will explain you whenever we are doing this. When we come to this resource section, I will exactly show you and practically how the changes happens and how Terraform. So everything will be taught practically with code. This is just a high level overview that you should know. Okay. Right? Any questions here, guys? If you don't have any questions, I'm going to revisit everything once again, and then we will move. Any questions here? Okay, cool. I think there is no question. I will just revisit this once again. Let me. Okay, I will revisit this once again, and then we can move ahead. Okay. Right. So, right. So now okay, let me explain you once again. I'm going to use maybe a different pen. Okay. So what I said, any code that you want to write, any files that you want to steer, you will do it with .ef extension. Okay. Anything that you want to create, you wanted to first of all write the relevant provider block. So whatever resources that you're trying to create, you will write relevant provider block with proper authentication, because this authentication will be used by Terraform to make a communication with the provider. Only if the authentication is successful, the provider will allow you to create this resource, or else you're going to fail. Okay, so you can write whatever code. Here we are creating an EC2 instance. When you execute this, when you run a Terraform apply, and the authentication is successful, you will be able to create the EC2 instance. And Terraform not only creates this infrastructure, whatever infrastructure the Terraform provisions, it will update in a file called a state file. Okay, that is called your desired state. Whatever actually running on your provider is your current state. All the time, whenever you run a Terraform plan or a Terraform apply, Terraform will make sure that your current state and desired state are equal. Whenever both are equal, whenever there is no drift, it is going to say, hey, boss, you're good. Infrastructure is up to date. But whenever there is some manual change, somebody has done a manual change or something, you're going to see this message saying that there is 1 to change or 2 to change or 3 to change, depending on what is the actual drift. Because if there is a drift, it is clearly going to show you what has drifted and how it should look like. Okay. Whenever you see a drift, you have two options. One is that just reverting back to the previous one, means reverting back to what you feel as per the code. Means whenever there is a drift, either you can go back to the previous state, that is one. And second is that you want to keep the drift. Keep the drift, and then you will make sure whatever is in drift, you want to keep it. Okay, in that case, one is that if you don't want to keep the drift, you want to revert, you will just go into a Terraform apply. But if you want to keep it, you will update the code in such a way so that it will no longer show as a drift. So these are the two things that you can do. Okay, is it clear, guys?
Yes.
Cool. Thank you. Okay, so now this is all about I wanted to teach about how Terraform works behind the scene. So now what we're going to do is I'm going to open now Visual Studio Code. So a couple of things I wanted to note here. So throughout this course, quite a few things here. Just going to remove this. Okay. Throughout this course, I'm going to use Visual Studio Code. Okay. So these are the tool requirement for all of you. So if you don't have Visual Studio Code, you can just go to Google and just type VS Code. And the one that's at the top, code.visual, just look at this logo, something related to Bluetooth, half of the Bluetooth. So just go and download this onto your computer if you don't have. So because throughout this course, I'm going to use Visual Studio Code. What I'm going to do is I'm going to create a new folder. So I'm going to file and add a folder to workspace. And then what I'm going to do is in my Terraform folder, I'm going to create a new folder called, I'm going to say, maybe then okay, I'm gonna create this folder. So this is our project folder, and then here is where we are going to write all our code. So what I'm going to do is every day when we connect, I'm going to create a new folder like this, class 1. Like whatever we are going to discuss that particular day, I will name the folder in that way. And whatever code I write, end of the class, I will just zip this up and send it to you guys. Okay. So then the requirement from the next class, I think next class will be on Wednesday. So the requirement for the next class is that I want all of you to install Visual Studio Code. Everybody should have Visual Studio Code installed in their computer. And the second thing is that you might need to have your free tier AWS account. So in the future classes, I will give you some assignments to go ahead and create something. So for that reason, you need your AWS access. And then it will be good if you can install AWS CLI. So for Windows user, if you go to your command prompt and if you type AWS CLI, okay, sorry, AWS hyphen version. Okay, when you run AWS hyphen version, you need to get something like this. Okay, if you're getting is not recognized as an internal command, which means that you don't have AWS CLI. So what I want all of you is that install AWS for Windows users, install AWS CLI. Okay, so if you if you need the link, I will just drop it in the WhatsApp group. You can just follow that link and create it. So these are the three requirements: Visual Studio Code, AWS CLI installed. So this is the confirmation message. So when you write a AWS hyphen version, you need to get some results like this. If you get a result like not recognized, which means that you have not installed it. So you need to go ahead and install that. If you want the link, I will send it in the WhatsApp group separately. Or else if you are good, if you want to do it yourself, yes, all good. Okay, and AWS one. So these three are the requirements that we need before you join the next. Okay, is that all right? Any questions here?
What was the third one? You said download Visual Studio
AWS CLI,
Code,
AWS CLI,
AWS
install
CLI.
AWS CLI. Yes, for Windows users. I think for Mac users, it is going to be really simple. I think, for Mac also you need AWS CLI, but the installation process is simple. But what I'll do is, just for the benefit of everyone, I'm going to send you the link in the WhatsApp group for both Windows users and for both Windows users and Mac users. You can just follow the documentation and get your AWS CLI installed. Okay.
Yeah, thank you.
Okay, cool. So now, we have 20 minutes left. So what I'm going to do is I'm just going to teach you some basics of providers. Okay, I'm going to create a file. So I'm going to name this file as provider. There is no necessary. I can name this anything. So for example, I'm just going to name something .tf. I say any file that you wanted to write Terraform code has to end with .tf. So I've given some random file name .tf. Okay, .tf. And then what I'm going to do is I'm going to create a new file called as readme.md. So readme.md is where I'm going to make all the documentation. Okay, so since this is not in .tf, Terraform will ignore this file. Okay, as I said, Terraform will always look for only for files with .tf, and there is one other exception I will tell you. But for now, think of Terraform will look for files with extension .tf only. Anything, any other files with any other extensions, Terraform is not gonna look into. Okay. So now let's say, how should I write my provider block? So this is how you should write your provider block. So you will start with the keyword provider. Within the double quotes, you will specify the name of your provider. Okay. And then you will open your curly bracket and close your curly bracket. And inside this, so this is called a block. Okay. This is your provider block. Provider, within the double quotes, you will give the name of the provider, and then you will start the block. Inside this block, there is a lot of documentation available of what can go inside this place. Okay, that is arguments. So whatever arguments that you can write inside the provider block is already documented. So we need to refer the document. Before writing anything inside this block, we need to refer the documentation and write. Because this is the basic template or a basic syntax to write your provider block. Okay, so this is a thing. So now let's go ahead and write an actual provider block. So I'm going to write provider, and in here we are going to look for AWS. So AWS, and then I'm writing a block. Okay, I'm going to save. Okay, so name. So the name is case sensitive, so you have to exactly write as per the documentation. So here I have purposefully written it as wrong, okay, because I wanted no one to assume that it is going to be capital or it is going to be one capital like A capital and WS or all small, nothing like that. So whenever you want to write a provider name, the recommendation is that just go to the documentation. Okay, so as I said, how you can go to registry.terraform.io, click on providers. So if you want to work with AWS, click on the AWS block, and then whatever name that you see here is their actual provider name. So here if you see, the provider name is AWS, all lowercase, right? So you go and write A. This is your provider block. Okay, so what else can go inside my provider block? I will show you. So now, as soon as you land on the AWS provider landing page, so there is an option, there is a link called documentation. You will click on the documentation. Okay. On the on the left, everything that you see on the left is all the services that AWS currently support. Okay, so you have backup, you have cloud formation, you have code commit, you will have EC2, EFS, every services in which you can use Terraform to create it, right, will be available here. And then provider. So in the middle is where you will see the provider. So these are provider level documentation. So I said, right, what can go inside this and how things can go inside this will be documented here. Okay, if you see the AWS provider, this documentation is purely for AWS provider block only. So if you see in this example, so on on the right you can see authentication and configuration. So which means that these are the different types of authentication for AWS, and then arguments. So these are the arguments. So clearly it says that the following arguments are only supported inside provider block, because if at all you wanted to write anything inside the provider block, okay, anything you want, because I can't write city equal to Dallas, for example. I can't write like this because city is not a valid argument. Because if I go back to the documentation and if I look for C, there is only one in C called as custom CA bundle. I don't see city. So which means that when you're executing, this is going to fail. This is going to not pass. So whatever you want to write inside this, it has to come from this document. Okay. So for now, I'm not going to write anything. Maybe I will write region. Okay. I will use this region. Region is an argument. I'm going to go back here. I'm going to write a region equal to, I'm going to say US East 1. Okay. I'm going to, okay. So this is one of the argument, but as I said, there are a lot of arguments. If you look here, so there are too many. So this is the argument reference section. So if you see, there are a lot of arguments for different needs. So depending on the needs, we can use the argument and specify a value. Okay. Right. So now what happens? So I've written a basic provider block today. So now let's see what happens when we execute this. Okay. When we execute this. Okay. Before executing this, we need Terraform binary. Okay, before executing this, we need Terraform binary. So what I have done is, so what you can do is, first of all, if you're a Windows user, what you need to do is, you need to go to terraform.io, and then there is a download section. Go to this download section, and then when you go to download section, you have a different operating system, you have the option. So for Windows users, for Mac users, run this command. These two commands will be enough. But for Windows user, you just click on. So when you see the binary is nothing but executable. That is what I'm saying. Binary is an executable. So 386, you see 386 an AMD version. So if your laptop is AMD version, download this. I think majority of the computers should be 386. But if you are specifically AMD, you need to download this. The rest of the guys can just download this guy. Okay. As soon as you click, it is gonna download it for you. Okay. It is gonna download it for you. And then as soon as it is downloaded, what I wanted you to do is, it is gonna be in a zip format. Okay. It's always gonna be in a. Just give me a sec. It's always gonna be in a zipped format. Okay. It's always gonna be a zipped format like this. So what you need to do is, you need to just extract. First of all, extract it. Okay, it's going to extract it. So as soon as you extract, it is going to give you a folder like this. So you have the terraform.exe here, correct? Just copy this exe into the current folder. Okay, so where I am working here, right? I'm working in this class folder. What I'm just going to drag and drop inside this class 1 folder. Okay. You can set it as an environment variable. I will let you know in the next class how you want to set the environment variable. Until that, just copy this executable directly inside your folder that I'm working. So we are currently working in this folder, class 1 provider folder. So I have dragged and dropped the exe here. Okay. And then I can go to my command prompt. Okay. I'm going to go to my command prompt. So how can people might feel difficult to use command prompt. So how can I open from a particular folder? Again, you can click here There is something called as Reveal in File Explorer. Okay, click here. It will take you to the exact folder where you're working. Just open this folder. You can see all the content, like whatever content that you can see in your Visual Studio Code. Okay, whatever content that you're seeing in your Visual Studio Code, you will be able to see here as well. So here in the address bar, right, you have an address bar. So just type CMD. Okay, select everything, write CMD. What it will do is it will automatically open a command prompt directly from that exact location. You don't have to move it. So go to the folder and open CMD. It is going to exactly open it from here. Okay, and from here, the very first command that we are going to learn is Terraform init, because Terraform init is the very first step. It will initialize. That is the first command that you need to run. Okay, so now before I run Terraform init, I wanted you to look into my left. So currently we have only 3 files. One is README, some random file with .tf where we have written the provider configuration, and then we have a exe. Okay, we have the exe. Now, if I run Terraform init, you will see another folder will be created automatically there. Okay, so I'm running Terraform init. You see here, it will create one folder right now. Just still installing. Let's see. So what happens is, see the .terraform folder, it just created a .terraform folder here. And it says, let's see one by one, initializing the backend. We have not given any backend yet because backend will come later. So we have not done anything with the backend. So it started initialization and then it just skipped. And then it is initializing provider plugins. So what provider we are using? We are using HashiCorp's AWS provider. So what it is doing is it is finding the latest version of your AWS provider, and then it is installing 4.49, because 4.49, if I go to Terraform, registry.terraform, and I'm going to go to the providers. I want to look into AWS. What is the latest version? The latest version of your AWS is 4.49. So what Terraform in this command will do is it will automatically install 4.49. Once that is done, it is going to successfully complete your installation. So that's the reason you are seeing this .terraform directory. So now let's see what is inside this .terraform directory. If you look open inside this Terraform directory, it is going to create a lot of folders. Okay, so it has created a folder called provider, registry.terraform.io, HashiCorp, AWS 4.49, and since I'm working on Windows, it says Windows 386. And inside this, what it has done is it has actually downloaded an exe for me. Okay, so now you can ask me, what is the difference between this exe and the exe that we pasted here? Okay, exe is the exe of your AWS, because now whatever resources that we write and execute, Terraform wanted to communicate with AWS. So this is that exe. So Terraform, to work with AWS, this exe is required. Terraform will automatically download this when you run Terraform init. But in order to get this, here we are running a Terraform init command, right? For this command to write, with this command to execute, this is Terraform only exe. Only if this exe is available, you will be able to run Terraform. Because or else if you run Terraform init, it is going to say it is not recognized as an internal. So you got an error earlier, right? So like if you run AWS, I'm going to show this. If you run Terraform, okay, something. I'm giving a wrong command. What happens is when you run Terraform init, if you don't have this Terraform exe and if you run Terraform init command, what it is going to do is you will get a similar kind of error, like it is not recognized as an internal or external command. Okay, so for this not to happen, if for successfully executing something, what we need to do is we need to have this exe. This is related to Terraform only. But for Terraform to work with AWS, when you do a Terraform initialization, this exe will be automatically downloaded inside your .terraform directory. Okay. Any questions? Any questions here?
Uh, yeah.
Yeah, go ahead, Subra.
Yeah, I got a quick question.
Mm-hmm.
So this is strictly relevant to AWS because you brought AWS library, and I see that you Terraform. So on a multi-cloud, let's say if a developer is working on a multi-cloud, would he has to create a new folder, or it will be same Terraform.exe?
See, no. What I'm saying
Would-
is, this is common. This is something that everybody needs. This Terraform.exe is everybody needs. Okay, this Terraform exe will not look whether I am AWS, whether I am GCP or Azure. This is common. If at all you wanted to execute Terraform commands, this Terraform exe is mandatory. Okay, but depending on your code, this .terraform directory is created depending on your code. So now in the code I've specified, I wanted only AWS provider. Okay. Now let's say if the engineer is working on multi-cloud, which means that I need both AWS and Azure. What I'm going to do is you will have to write another provider block for Azure. Here. Okay. So Azure provider, you have to write like this. Okay, Azure provider, you need to write like this. So now, when I execute Terraform, I'm going to open a command prompt because mistakenly I've closed it. Now I'm going to bring up my command prompt. Okay, and now what happens is, so last time when we executed, only AWS provider was there. So it downloaded only plugins related to AWS. So now when I run Terraform init again, this time it will try to initialize both your AWS and Azure. Okay, both AWS and Azure. So this time I'll let this complete. I will explain you in detail. So now if you see, there is only AWS folder. So now you should be, as soon as this completes, you should see two folders, one for AWS and one for Azure. It should be like a structure. Let this complete. Okay, the initialization is complete. Now if you see the folder structure, so you have HashiCorp. Inside HashiCorp, you have two folders. One is AWS and one is Azure. If you expand AWS, it is going to say, hey, I have downloaded a 449 version of Windows. That exe is here. And for Azure, if you see, I have downloaded 3.38 version of Windows. And this is your Azure related exe. So this Terraform is common. In order to execute Terraform commands, this exe is mandatory. Then, depending on what you have in your code, so if you want to work with AWS, you will write AWS provider. If you want to work with Azure, you will write Azure provider. Or sometimes if it is a multi-cloud and if these two needs to be in the same place, because some people with the same folder, they will create because they want to create a link between AWS and Azure. In that case, you need to write both the provider here. So depending on what provider you write, Terraform during the initialization is going to download the right plugin, because only through this plugin Terraform will be able to communicate with your AWS, because this exe is a binary of your Terraform to communicate with your Azure and AWS. Does it make sense, bro?
Yeah, that's fine. Yeah.
It makes sense to everyone. Is that clear for everyone? Any questions? Okay, cool. Right. So now if you see, I wanted to explain all the other stuff which is automatically created. So this .terraform directory was automatically created, and this Terraform log file was automatically created. Okay, I'll tell you why this log file is available here. In the previous versions of Terraform, right? Maybe because I started working on Terraform from 0.8 version. So 0.8, 0.9, 10, 11, 12, 0.13. After 0.13, they went for a major change, which is 1.00. And now it is somewhere in 1.113 or something. So Terraform has evolved a lot. So in the previous version, when I was working in 0.8 and 0.10 versions of Terraform, whenever you do Terraform init, so whenever you do Terraform init, what it will do is it will automatically delete this .terraform directory and it will re-download everything. So just now I ran Terraform init. Next time when I run Terraform init, what it will do is it will remove this directory automatically and then it will recreate it with new. Okay, but that was not right. Because it is waste of your time and waste of your data, because every time these exes, right, these exes are anywhere between 200 to 300 MB. Okay, so every time it is going to download 300 MB freshly, and that was not good from a timing perspective as well and from the data perspective as well. So what Terraform has done is they introduce this log file. So what happens is whenever you do a Terraform initialize, it will make a note of the version that you're using with a particular hash. Okay, so now it says provider registry Terraform HashiCorp for AWS version 4.49. So which means that the 4.49 was what is already installed here. As part of the initialization, this was already installed. As part of initialization of Azure, this is already installed. So that is the reason if you see, last time we successfully initialized AWS. So this time only we added a new block for Azure. So there was no change to this AWS provider whatsoever. So if you look at the logs, reusing previous version of HashiCorp / AWS from the dependency log file. So what it does is whenever now you do a Terraform initialization, I'm going to clear my screen. Whenever I do a Terraform initialization, it is going to look for this file and it is going to look for the version. If the version is already available, instead of downloading it freshly again, what it says is I'm just going to reuse. So what it is doing is it is checking first what you have currently in the folder. If you already have the right version installed, it is not going to reinstall again like in the previous version. So it is going to check this dependency. This is a dependency log file to understand what version is already installed. If the version is already installed, it is just going to say, hey, I'm going to reuse, and it is going to complete the initialization. If something was not available, then what it is going to do is it is going to freshly download your stuff. Okay, is that clear? Any questions here, guys? Very silent.
I don't know if this is a question, but I wanted to ask, why didn't you use the terminal up there, like the one up? Why did you have to go all the way to the folder, the file explorer?
Okay, a very good question. So okay, I will tell you that as well. So everyone, you don't have to go to the as Clarice mentioned, you don't have to go externally. You can just click on, whatever folder that you're working, right click, you can say open in integrated terminal. And from here, you can choose command prompt and you can do the same thing. Whatever I did, you can do the same thing on the same page. Okay. But here, I wanted to, because if every time when I want to use this, I wanted to scroll this up, scroll this down, and sometime I'll be having code. I have to accommodate this according to the code. And the font size, the font size here is something that we cannot change. Okay, so even if I'm able to change it, the font size will be too big. So I need to scroll a lot up and down. So what I prefer doing is, since I'm teaching, I wanted it to be comfortable with everyone. So as soon as it is on a new window, it is better. So now I can, explain the code and both the things parallelly. I can see, hey, this is the code and this is the properties that we are given. See, the properties are available. So, this will help me to teach better rather than jumping between different things. That's the reason I use the external one. Uh, if you guys are comfortable, you can directly, as I said, you can directly open the terminal from here and choose, it is going to give you a lot of different options. Choose command prompt and you can start working directly in one page. Make sense?
Thank you.
Okay. Any other questions, guys? Any other questions? Okay. Right. I think probably we can close the call today. Okay. So we have done the basics of provider. So in the next class, what we are going to do is we are going to extend a little bit on the provider, because now whenever you run a Terraform init, it says that I am always fetching the latest version. Like if at all I wanted to cherry pick a particular version and work with that, what should I do? So those things we will explain in the next class. And then also what we will be doing is, as soon as that is done, in the next class, we will be seeing a lot of variables, or there is variables and outputs. We are going to see variables and outputs together in the next class in detail. Okay. Yeah, that's it from me today.